Hi, I'm Linda Matthew. I've been working for TechSearch since 1997 now, and we've seen a tremendous interest in advanced packaging. And packaging has kind of transitioned over the years from being a sort of an afterthought to really being an integral and critical part of the technology, and also a critical part of the cost, which is a big part of what drives the interest. I recently worked on a section on integrated photonics packaging for our Advanced Packaging Update, which is a quarterly publication that goes out. And this was really interesting because we took a look at this 2 years ago, and with this version, we took another look to see what's changed. What's happening now is that we're really moving towards adoption of integrated photonics. And the driver for that, the immediate driver in the short term, is the data center. At this point, the implementation is not so much a volume play for the integrated photonics specifically, but it's strategic to support the sales of the hardware and services. And there's a number of factors coming together to potentially move integrated photonics forward rapidly at this point. The first one is the technical capability of CMOS fabrication is becoming more available for the photonics. And so one of the things to keep in mind here is that with integrated photonics, basically what's happening is a number of photonic devices, the photodetectors, the waveguides, the filters, modulators, and so on, and the laser and light source, of course, are being put together onto one component. So in the same way that we have integrated circuits in electronics, this is integrated circuits in photonics. And in that situation, the substrate can be silicon. The advantage of silicon, as I just said, is this ability to use the existing CMOS processes, and that's huge. The other substrates that are used are indium phosphide and gallium arsenide. And the reason for that is that these 3-5 substrates have the ability to laze, which is obviously critical when you're dealing with something where you need a light source and a laser. So when we're working with silicon, the laser has to be added somewhere either outside the package, or it has to be added as a heterogeneous part onto the chip or onto the package. But regardless, the installed capability of silicon is very, very powerful, and that's being used now more for the integrated photonics. Other things coming online is the automated processes are being developed, investment is increasing. The cycle time on runs is improving, and these are the MPW wafers, the multi-project wafers. What's happening is that as more people start to work on these devices, they become more predictable, and that always helps cycle time and also the development. Design rules and PDKs are becoming available, and I'll show you a slide on that in a sec. And also the equipment suppliers are beginning to make the equipment to automate these processes. So this is a slide from HP Labs, and what they're doing is they're working together with people to implement the infrastructure to support this technology. So basically they're putting together an ecosystem for the entire process. And this particular slide, what it shows is the implementation of different kinds of packaging for silicon photonics. If you look on the left, you can see the first version that was implemented, and this is a pluggable connector that basically goes on the edge of the board. And then over time, we shift towards the right, and you can see on the right-hand side, there's a different form of integration, another form of integration where now what you're integrating, so the first form of integration is at the chip level. You've got these photonic devices that are integrated onto the chip. And then the next step is going to be integration of the electronics components and the photonic chips onto a single package that's also referred to as co-packaging. So that's going to be sort of the next step that happens. And you can see the timeline for this. Let me show you one more slide to follow up that thought. So here is the co-packaged version in the drawing at the top of the slide. This is an Intel slide. And they've demonstrated this now. So you can see that you've got the electronics, the switch ASIC in the middle of the package substrate. And then around it, you've got the optical interfaces. And so the first product that Intel shipped was the 100 gig transceiver. They've shipped over 3 million units of those now. That's in the pluggable connector format. And right now they have a run rate of 2 million units per year. What they've demonstrated now is the co-packaged version of this, and that's the drawing. And the driver for this is as we go to the very high bandwidth switches, and it's likely that between 25 terabits per second and 51 T is going to be when this particular configuration becomes essential. So Intel in their photonics work can also put lasers and amplifiers and the other active components onto the silicon platform using the CMOS process. And what they do is they bond the indium phosphide to the silicon wafer, and then they build the lasers at wafer scale. And so that's just a quick overview of what's going on in silicon photonics, and specifically with regard to the packaging. And all of these things can be found in the advanced packaging update. And we will be doing another overview of what's happening with silicon photonics soon. Thank you.